Go.
Ta-da! Here we are. Okay, so we're making more comparative inferences today. We are not making the same kind of inferences. So last week in 6.3, we were making inferences over box and whisker plots was our focus. So we were looking at how do you compare with median? Or what was the other way we made comparative inferences? Claire? Oh, we did, yes, but with the box plots, I mean. With the box plots, we used the median and we used
the interquartile range and the range?
the interquartile range was our focus, yes. So today, we're going to be looking at dot plots, like Claire remembered, and you don't make the same comparative inferences with dot plots as you do with box plots. It looks a little bit different. So, that's what we're doing today. Let's begin.
How can you use dot plots to draw inferences and compare data sets? Think about this question during the lesson.
Oh, I know. Can somebody explain what a dot plot is again?
Oh yeah.
The visual look of it should be pretty easy to describe.
Yes.
Bailey?
Yes. I think.
Okay, yep. Like a number line, right?
It was like, say you're surveying pets people like. You know, dog, cat, whatever,
Yep.
whatever people like, then dogs.
And dots. Yes. You will have a bunch of dots.
I can use 4 words.
What's that?
A dot with plots.
Oh,
How about a
a
plot
plot
with
with
dots?
dots. Yeah, there
Yeah, it's a plot with dots, yes. So if you have like the number 2 here on the number line and you have 4 dots above it, what does that mean?
there's 4 of those numbers.
There's 4 of those numbers, yes. So there's 4 people that answered 2, if that was our question. Bailey said you could put animal names at the bottom. You could put cat, dog, blah, blah, along the bottom. What is that kind of survey called? That's not what we're doing today, but it is a good review. If you don't have numbers on the number line, but you have words instead.
Word plot.
No.
Qualitative.
William? It's qualitative, yes.
Not quantitative.
Numbers is quantitative, words is qualitative. Dot plots are the only thing that can be used to collect qualitative data. We're working with only numbers today, but I wanted to review that with you.
Quinn collects data from a random sample of 20 7th grade students who participate in a youth fitness program. She compares the number of curl-ups each student completed in 30 seconds last year and this year. What can Quinn infer from her comparison of the data sets?
So, this at the bottom, curl-ups, I think they mean sit-ups. At least by the picture, I'm assuming it's a sit-up. I've never heard it as a curl-up, but that's what they're doing. So this is the collection of data from last year, how many they could do. This is the collection of data of how many they could do this year. This list right here is very unhelpful. Because for one thing, it's not in order. And you can't compare a list that long. Like, we need to be able to see it in some other manner.
Begin by displaying the 2 data sets in dot plots. Last year's data and this year's. Why are dot plots an appropriate representation for the data sets?
Why would a dot plot be helpful for this kind of data? Nathan?
There's a lot of numbers, and most likely same numbers.
It's
So
true.
yeah, so then you won't have to like count 1, 2, 3.
Yeah.
Yeah.
Could you have used a box plot? You
Yeah.
could have, but you would have had to put them all in order, split them in half, split the first half in half, split the second half in half, and I think it'd be quite a bit of work. So I think they chose a dot plot only because it's going to be a little faster than a box plot will be.
Dot plots show the distribution or shape of the data, and they suggest the center of the data and ways to measure the center. Now, let's use the dot plots to compare the two data sets.
Okay, what can you guys tell me for comparison? What can you tell me about just looking at these? What can you tell me? This is last year, this is this year. Give me some general inferences. Sam?
That they did better last year.
Look at the numbers down here. They had a lot more last year, like consistently. Jude?
That this year that kids are getting like more of them
Okay, how do you know that?
because last year like no kids got to 28 or 29 or 30, and this year you had kids getting all of them.
Yeah, last year we didn't have a single dot at 28, 29, or 30. And look how many we have at 28, 29, and 30 now. There's a pretty big group of them right here, and they're all higher than what they were before. Hannah?
In some places, they either did more of the curl-ups or they did less.
What do you mean?
So, in 21, the first year was better, and for 24 and 20, all those, the cluster, those are all more.
Oh, okay, yes, yeah. So when they drew this line here, what good is that? They said it in the phrase. Evelyn?
To like compare how much it went up and down, and that's basically.
Okay, it gives you the shape of the data. And when that shape is at the top, is kind of where the majority of your data is. So right here is where the majority of my data is, which is what, like 23, 24, 25? Right? Down here, where the top is like 27, 28, 29. That means they made improvements. There's something else about this one. What else do you notice about this one? As in comparison, I don't know what words to use without telling you what it is. Eliana?
So, the line is bumpier than the last year's.
What does that mean? Mateo?
It's more spread out.
It is. This, and Eliana said it's bumpier. Like it's not a nice smooth increase and then decrease. This one's a lot smoother increase, decrease. And it goes from 20 to 27, which is a range of 7. This one goes from 21 to 30, which is 9. So this data is much more spread out than this one is. That's kind of that bumpy feature to it, is the data is spread out. What does that mean? Since this data is so spread out, what does it mean about how kids improved or didn't improve, perhaps? Jude?
Some kids could have gone home and like they started like doing sit-ups.
Okay. So some really increased, right? And some
Some of them just stayed.
some of them may have stayed the same. These ones that were down here are still down here. So we made, some people stayed consistent and some people made huge gains is kind of what we can tell. Let's see what they say.
Last year's data has a mode of 24 and a range of 7. This year's data has a mode of 28 and a range of 9. When were the students, on average, able to complete more curl-ups?
When did they complete more? Last year, this year, neither year. Claire? This year for sure. That mode is quite a bit higher.
The number of curl-ups completed this year is generally greater than last year. But based on the shape of the data, not all students made the same progress. Quinn can infer from her comparison that the majority of her classmates were able to do more curl-ups this year than they were able to do last year.
So he said that she could infer that the majority of classmates can do more. Why can she not say all classmates can do more? Hannah?
Because some stay the same.
Some stayed the same. Good. But you can safely say the majority are doing more. Evelyn? What?
The thing is, with dot plots, you can't tell, like, if they have little numbers, like on the actual dots, like you label them, then you could figure out, like, if anyone actually decreased, because.
You could if you knew which dot was for which person. Yes, this is only in general. Okay, same kind of idea, but this time it's push-ups last year versus push-ups this year.
There's a lot more push-ups this year.
So same kids, same amount of dots, but what can you infer? What is, let me ask you some specific questions. What is the mode of last year? Carolyn? What is the mode of this year? Mateo?
7.5.
Oh, it's actually 7 and 8.
Oh.
Mode, you would say both of them. Hi. Must be a two, I don't know. So the mode here is 4, and everything is kind of centered around this. Let me take a picture of it. And I'm going to draw the shape around it.
Oh, wow. It's a lot more bumpier.
Okay, neither of these are super consistent
No.
because both of them have quite a few bumps in them. I maybe could have made them not quite so bumpy, but I did. The peak of this one is at the mode like it should. That's kind of where a big group of a bunch of people are. Down here, the big group would be at like 7, 8. So what can you say about this year's number of push-ups versus last year's number of push-ups? More or less?
Last year.
This year is more. Right?
Yeah.
Yeah, because in 7 and 8, you only had 2 kids, you had 3 kids for 7 and 8, and this year you had
And
6.
there's,
Yeah.
and last year nobody even did
And yeah,
11.
somebody never.
Right. Last year's max was 10, and there was only one person. One person at 8, one person at 9, one person at 10. Look at all the people at 8, 9, 10, and above. Right? There's a lot more dots on that upper end than there are last year. Did everyone make... Does it look like everyone made progress?
Yes.
Yes.
It does look like that because we have 1s and 2s here. Now our lowest is a single 3. So nobody made 1s and 2s. So the lowest here, definitely, they had to have made improvement because our minimum got raised. So it looks like everybody made progress. What about the range comparison? What's the range of last year? What's the range of last year?
10.
1 to 10 is 9, right? 10 minus 1 is 9. The range here
9.
is 9 as well. So it's kind of like you had this group and everybody went like this. The range is the same. What's going on? Just that warning? Okay. Okay, we've got to talk about this.
Mad.
MAD. It is, actually I'm going to have you write this down. It is, MAD is the acronym for mean absolute deviation. Write those words down and it's very fancy words for a much more minor meaning. So write it down and I'll give you a definition.
There's another central tendency.
Yeah, I suppose it would be. It's not a common one though.
What's the definition?
Hmm?
I learned regular definition.
Oh, I'm gonna give you the definition. They actually don't give you the definition. I don't know.
Too smart.
Yeah, I don't know.
Or maybe it's in the book.
Oh, I'm not too
Maybe
smart.
it's in the book.
Maybe.
Of course, no.
Okay, let me give you a definition. Mean absolute deviation. Here's my definition. Not a mathy definition, but this is my definition. The average distance average distance from all points and the mean.
It's like the average of a bunch of little ranges.
Yes, it is. You're not going to be asked to find the mean absolute deviation, but I'm going to show it to you because I need you to better understand what they're even talking about. So I'll give you a dot plot with just a few points on it so I can explain it. Ivan, do you have a question?
No, can I go first?
No. Are we ready? If you could create this dot plot, it's just gonna be a really small one. The number line is only 1, 2, 3, and 4, and I'm only gonna put a few dots on there. We'll put 4 dots.
Are the dots so big? What about two?
Hmm?
On a dot plot, could you put like half a dot?
No. No, because it's the answer for one person, so it's gotta be a whole dot. Yeah.
Is that green?
Yeah.
Oh. For some reason,
It is. Okay, so if you're gonna find the MAD, the mean absolute deviation, the first thing you have to do is find where the mean is located. So we have to identify the mean is where we will begin. The mean means you've got to add up all the points and divide by how many you have. So this is worth 1. Each of these dots are worth 3, and this is worth 4. So I'm going to do 1 plus 3 plus 3 plus 4 divided by 4 dots. So I would get 4, 10, 14.
You get 11.
Because I can't add.
11.
It's 11. 11 divided by 4. I didn't think, I was figuring that out, and I was like, that's got to be too high for that.
Wait,
but okay. It's 11. I just can't add.
I was like,
So it would be 2.75 is where the mean would be located.
But you can't have it.
No, not the MAD, the mean. The mean is at 2.75. So the mean is right here at 2.75. And what the MAD does is it finds the average of how far each of these 4 dots are from that 2.75. So how far is 1 from 2.75? Or it's just little mini ranges. So 2.75 minus 1 is 1.75. Then we've got 2 dots at 3 here. So how far is 3 from 2.75? 0.25. And I have 2 dots at that distance.
So could we just put
Yeah, you could do this differently if you wanted to. And then 4, how far is that from 2.75? Jude?
It is 1.25.
1.25. And there's still 4 dots. So you divide by 4 just like you did with the mean. What's your question?
Why do you have 2?
Yeah.
Why do I have 2.25s? Because there's 2 of them.
Oh.
So both of these are 0.25 away from that line. That's why I have 2 of them. So every dot has to have a distance associated with it.
I believe.
So if we add those up, that's 2, and 1.5 would be 3.5, divided by 4. Ooh.
So it's 8 first.
Can somebody just grab their calculator and divide that for us?
I think it's 0.875.
7/8.
I think it's 0.875.
I think you're right. Let's check it though.
How we
It's 2.75. 8.75. It's 8.75.
it can't be 8.75.
She has to calculate.
0.875.
Is this?
0.875?
Yeah.
Yes. So what we have now, this 0.875 is the average distance of the points from that mean. So what does it tell us? What does the MAD tell us? Like in inferencing terms, what does it tell us? Jude?
8.75.
I thought the MAD tells us that
You don't know?
no.
Okay, Eliana?
It gives us kind of a range,
Mm-hmm.
but it's
Okay, how about, I'll tell you. It tells us how close things are to that mean. How centered everything is to that mean point. So it's basically an idea of how close are things in comparison to each other. So 0.875, that means everything is pretty close to the mean. Right? Okay, let's go back to that problem that we were looking at a second ago. So on the curl up problem that we had, they found the mean and the MAD. So the mean was 23.6 for last year, 26.6 for this year. Didn't we say they did more this year than last year?
Yes.
So the mean confirms that. What do you think about the MAD comparison? What does it mean that the MAD from last year was less than the MAD from this year? William?
It's more spread out. This year is more spread out.
This year, there's more variability is what that would mean. So the MAD tells us more about variability like we talked about last week. This means things are less centered than this one.
Okay, so let me get this straight. The MAD, what's the perk, like, when would you,
It's another measure for variability.
so would, like, if you, like, had a job, what would, like, many people use that?
There are, have you guys ever heard of the bell curve?
No.
Sorry, no.
No, you've never heard of that?
Not this name.
Okay, well, now you will.
Oh.
So there's something called a bell curve, and it looks like, I'm gonna try to draw it, okay?
Wait, is this?
Oh.
That's a bell curve,
Oh.
and what it means is that everything is distributed perfectly. Like there's none of those little bumps or anything in it. That's what a bell curve is. Like professors at a college, they try to get their grades to be within the bell curve. So what that means is
Oh yeah.
these are like the kids with 98, 99, 100s. These would be like the B kids. These would be how many kids have C's and D's and F's. So like a perfect grade book system would kind of look like this if I mapped out all the data. So what statisticians will do is take, maybe it doesn't necessarily look like a bell curve. Maybe it is some of the ones that we've looked at, you know, that are kind of off to the edge or bumpy or something. And they take, it's more than just the MAD, but that's the beginning of what you're learning. And what it does is it splits this data into parts so we can evaluate what's going on. I don't know if that answers your question or not.
Okay, so when do we get to do bell curves?
That usually doesn't come in until like college statistics classes.
We got a ways to go.
So I did.
So,
Statistics.
yeah, you guys are a ways away from being able to study that yet.
I'm gonna learn statistics.
There are statistics classes in high school that you can take that you would learn about that.
I don't take math in college.
You do?
No matter what career you're going into, you have to take a basics.
Wait,
I'm gonna go work at home.
you have to take basics. What is Miss?
What?
Can you do like something in like high school that like you do your basics in high school then you don't have to do it in like college?
Sometimes you can. Yep.
Why did you take my
All right. What do you think of these dot plots? What do you think of these dot plots? These are push-ups again. It's a different dot plot from before, but it's push-ups last year versus push-ups this year. Donnie?
This year is much better than last year.
Okay, so this year they're doing many more push-ups than they did last year. What could be your proof behind that?
The chart.
What proof can you state? Donnie, since you said it.
The main concentration of dots are higher than last year.
Okay, so what would you call the main concentration of points?
7
What are those called though?
points on the plot. Dots.
William? Those are the mode, okay? So the modes are located at 4 and 5 here. The modes are located at 7 and 8 here. So the modes are higher, which means our data is higher. What else could we use to prove that they did significantly better this year than last year? What else? William?
Everybody this year did at least 6 push-ups.
Okay, so you could compare the minimums. The minimum here is 1, the minimum here is 6. So everybody had to have done better. Okay? What else? What else could we use to prove that people did better this year versus last year? Mateo?
The amount of people that did each, like, for like the most people did 7 and 8.
Mm-hmm. So that's the mode, right? Okay, what would you say about the range? What's the range for last year?
6.
What's the range for this year?
6. But it's better.
It's better.
Like the range wouldn't be like.
Hold on. We're not moving on until I can get everyone's attention. I don't know what you're laughing at. I don't care what you're laughing at. I just need you to stop. What does it mean that the ranges are the same? The range for last year is 6 and the range for this year is 6. What can we infer based on that? Evelyn?
It's going to stay the same, like either way for greatest or least.
Okay, I get what you're saying. Eliana?
Variability is the same.
Variability is the same if you want to use a math word. Variability is the same. That's good. William?
Neither is more consistent than the other.
Good. They're equally consistent is another way of stating the variability didn't change. Doesn't it also imply that everybody increased equally? If the variability stayed the same, you've got this group, and now the entire group is up here, I would infer that everybody increased equally. Not exactly, but relatively equal. What did they say? They said there are more dots for greater numbers of push-ups completed this year. So based on the shape of the data, students generally did more push-ups this year than last year. So we stated that. Harry can infer that more of her classmates were able to do more push-ups this year. Okay, we already had that. Okay, what do you think about this one? Different dot plots. Same push-ups last year, push-ups this year. Very not the same dot plots though. So give me a general inference from last year to this year. Jude, I'm gonna need you to go in the hallway. When you can stop laughing, you can come back in. Okay, what can you infer from last year to this year? Nathan.
Last year was a lot more stable, I can say. Like, just by seeing, there's a much more like constant like number of people doing push-ups than this year. This year's a lot more spread out.
Okay, so I can see what you're saying. I'm thinking it's based on the cluster.
Yeah, cluster.
Okay, there's a cluster of data right here. Whereas here, you don't have like a specific cluster. So I can see what you're saying, but be careful because what is the range of last year? 10 is the max, the minimum is 0. 10 minus 0 is 10. So the range here is 10. What's the range here? 9. So the variability is actually less on this year. But these ones are all grouped together, so I get what you're saying on that. Donnie?
There's more good than there was last year.
Use different words than that.
There is more higher numbers completed than last year.
Okay, so you can say generally students did more push-ups this year than last year, right? More push-ups were done down here. What is the mode of this year? Jude? 9, 10, and 11. What's the mode up here? 3. So the mode went from 3 to 9, 10, 11. So they increased by quite a bit, we could say. William?
Last year has outliers because it's like they have a 0 and then they have a 10, so it's kind of like an out there.
Yeah.
The 0 may not be as much as an outlier, but that the 10 is.
9 and 10 are definitely outliers. So 9 and 10 used to be outliers. Now they're the normal. Can you see that? Now if anybody had an outlier, it might be 3 and 4. You know, the low ones have turned into the outliers. All right, questions? No? All right, I think I'm gonna let you get to your work. Yep, go ahead.